Ms. Hager Fathi, an assistant, please applause, an assistant lecturer in bioarchaeology at Ain Shams University in Egypt. After that, Dr. Nihel Ziadi, an experienced marketing PhD and certified trainer who brings insights from her diverse professional background. Mr. Youcef Benrached, a master's student in artificial intelligence and big data from Khamis Miliana University in Algeria, with expertise in computer vision and healthcare applications. We have Dr. Samia Benadda, an expert in microbiology, head of the Department of Al-Hadi Place Hospital in Algiers. She combines her expertise in diagnostics and public health strategies with innovative digital tools for learning. Now we have from Palestine, Dania Abu Reish. She holds a bachelor's degree in business information systems from the University of Jordan and currently pursuing her master's degree in informatics at Palestine Polytechnic Universities. Unfortunately, Dania couldn't join us today, but we were pleased to welcome her supervisor, Dr. Radwan Tahboub, Vice President for IT and Digital Transformation at BBU, who will be presenting on her behalf. And then we have from Tunisia, our guest, Dr. Asma Hdawi, a computer science researcher who has developed AI-driven frameworks for collaborative learning. And finally, or she's not here. Okay, so let's give her. These remarkable researchers will each deliver a presentation. After their presentations, we will give you some time to vote for their participation, depending on their presence, depending on their research. We will give you a QR code that you will find on the screen, and then you can scan it and vote. Hello. So let's introduce Dr. Ines Sberi, an assistant professor and researcher from Tunisia, focusing on optimization algorithms for real-world problems. Thank you. So again, we'll hear their presentations one by one, and then we'll give you time to vote for the best participation, and then we will announce the result during the closing. So without further ado, let's invite our first speaker, Dr. Amal, please.
الليزر كيف بقلب السلايدات؟ هاي السلايدات حتلاقيهم هون. لا كيف بقلب؟
Clicker. Let's find a clicker. هو
هذا اللي وراه؟ هذا اللي وراه كده؟
أيوه هذا اللي هيك.
اوكي. لا عايزة اللي قبل.
Yes, please. Just one, sorry, an important note. Each will have maximum 7 minutes, so eyes on your clocks. The timing is part of the voting. Thank you.
Good evening, esteemed colleagues and guests. My name is Dr. Amal Shaikhah, an assistant professor at Faculty of Medicine from Gaza, Palestine. Today, I'm thrilled to explore with you the intersection of cutting-edge technology and healthcare, focusing on how machine learning algorithms can revolutionize the prediction of treatment outcomes for colorectal cancer patients. In this session, we will travel from global data, global statistics to the heart of Palestine, uncovering the potential of data-driven insights in reshaping cancer management. My goal is not just to present research, but to spark a vision of how computational tools can provide hope, precision, and better lives for patients worldwide. My paper is application of machine learning algorithms for predicting the outcome of therapeutic intervention of colorectal cancer patients in Palestine with a global comparison. Introduction about colorectal cancer. We know colorectal cancer ranks as third most common cancer worldwide, with over 1.1 million new cases diagnosed annually. It is also a second leading cause of death, cause of cancer-related death, climbing nearly 1 million lives each year. The incidence of colorectal cancer highest in middle and high-income countries due to lifestyle such as smoking, alcohol consumption, obesity, and unhealthy diet. If we're talking about the incidence of comparison between global and Palestine. In global, we have over 1.9 million new colorectal cancer cases. The incidence is 19.5. In Palestine, the incidence is 13.6. More statistics as gender disparity in colorectal cancer. We can see globally and locally colorectal cancer is more prevalent among men than women, with 12% prevalence in men compared to 9.8 in women. The role of the role of machine learning algorithms Okay, the aim and the objective. Okay, the data. We have in the project research, this project research is the first research accepted by NIH from America. I'm the first Palestinian woman from Middle East sign the agreement with NIH in America with this project. We have two data sets. The first data set is from Ministry of Health in Palestine. The other data set is from National Cancer Institute from America. We employed multiple algorithms, including logistic regression, decision tree, gradient posting, and using hypermeter. Let me explain how machine learning is work. Here is the first step. We train the data. We put the data, then conduct the machine learning algorithms so the decision will survive or unsurvive. Then we repeat, train another time, then train for third time until the model is valid to take decision about survived and unsurvived. Until it learns from the patterns of colorectal cancer, we start the next step is the test. Now we put the data about the model, then the model tells us if the patient is survived or unsurvived. The machine learning for a prediction, we put the data, then the model of machine learning algorithms will train, then we put a new input, then we get the prediction. In training, we just extract the patterns, but in test, then evaluation, we know the decision about the data. This is also machine learning and how هحاول أسرع. Okay, this is the first data, the first statistic data for Palestine, then the statistic data for global data. This is the correlation matrix for the data. Then the data preparation. In the second graph, we see unbalanced data. The deaf people is more than the live people, or the opposite. So before we start the machine learning process, we should balance the data. So we do the data preparation, balancing, and set up as the first graph. This is the comprehensive features set model. We use 3 algorithms, KNN, random forest, and XGBoost. This is the rock curve. We can see the difference between the 3 model, which the difference between the percentage of the accuracy of the 3 models. Okay, I can see 95, 98. No, I can't see the number. You can see the number. This is the feature important. We can see that age is the most feature important for all the data. So we can say age, diagnosis, stage, grade. We take the first 5 features which include in the model. This is the first 5 important feature. This is the correlation matrix for the global data. Now we can see the global data. We can see the global, in the comparison, the global data is more valid than Palestinian data. In Palestine, we have more challenge in the healthcare sector. Here is a feature important in the global data. We can see now the stage is the first important, not the age as Palestine. The stage is the first, then age, then diagnosis, then grade. Here we can see the comparison, final comparison between Palestinian data and global data. We can see as XGBoost is the perfect model for prediction. In Palestinian data في comprehensive model 74 بينما but in global data 85. Okay. Conclusion. In our conclusion, as I say, we can the age-related trend observed in tumor grade distribution and the success of XGBoost in predicting therapeutic intervention outcome. The recommendation, we need to use this model, but in the different and large data set and different demographic data. I'm working on Palestine and global, maybe other researchers working in other demographic data. Thank you.
Thank you, Dr. Amal. We now welcome Ms. Hager, please.
Assalamu alaikum. Good evening. I'm Hager Ali, Assistant Lecturer of Bioarchaeology at Faculty of Archaeology at Shams University. And this research is a part from my PhD thesis, which is talking about climate changes and its impact of the Maadi population in the prehistory in Egypt. This research, I took about just the climate changes and its effect on the diet. And I'm still doing my research to extract lots of the effects of the climate changes on the population, like paleopathology or trauma or conflicts on the water resources. At the first, I want to explain what is the meaning of the climate change. Climate change refers to the long-term shift of the temperature. Climate change is referred to the long term of the shift of the weather temperature, like the high long-term temperature of the high temperature in the society, or rainy period for the long time, or low the temperature in the long time, which affected on the people for the many different diseases, like the diseases of the airborne diseases, or diseases of the waterborne diseases, or foodborne diseases. Osteoarchaeology analyzing, or specifically, I'm here to talking about the dental analyzing, which is the branch of the osteoarchaeology. It's analyzing the human remains by consistency, the dental health of the people, and which to know the interaction between the dental health, their dietary, and their healthcare hygiene of their tooth, and its impact to how they adapt to this climate change for the long time on the population. يعني let me explain it in Arabic. يعني مثلا they eat specific food for the long time, or they have a pathology in their teeth which يعني impact them to die, like the abscess, which in the different cases which let people die. So from the dental analyzing, we also indicate to the type of the plants and animal of the food which available in this time, and dental analyze offering insight of the chemical composition of the water, in which if the water was clear, or what was have something which like مثلا in الwater دي carry some of the حشرات أو insects، أو مثلا بعض المواد الكيماوية اللي جت مع الفلودز الفيضانات في فترة زمنية معينة. Maadi, one of the civilization which was in the past human of the ancient Egypt, from the people knowing the writing and reading أصلا. So it's very important period to understand the climate change, how the people adapt with it. Maadi witness a rainy period for the long time, and this period with heavy rain and the drop in the temperature follow after a of the non-period, which affected the people. They have to make a small immigration from the north to the south to one of the sites now here in Egypt, in the Wadi Degla. If someone here, this is in Egypt, it's a famous site. And this symbols, or specifically my study, is depending on the symbols of the human remains, bones, skeleton, and skulls, which I used it to know the effect of the climate changes on this from the samples. The totaling of the samples, 54 samples, consistence between skulls and the fracture of the bone. The aim of the study to understand, I'm sorry for not changing the stations, I'm sorry. Okay. The objectives of the study to understand or know what was the dietary pattern of the Maadi population, and if they eat a specific or type of the food for the long time or not, and if this dental diseases is for يعني incidence for just for the female or just for the male, and if it's for the young adult or middle adult or old adult. One of my methodology is to understand what is this. I have a skeletons, I have a skulls, but to know how the people, if this diseases يعني كانت incidence for the young or the middle, for age or sex, to identify for this human remains. أول حاجة هي sex determination for skulls. So I will explain it in Arabic to make it easy because we are different specialists. أنا عندي 54 عينة، فبالتالي بدأت إن أنا أعمل زي بطاقات تعريفية كده لكل حالة عندي. هو عنده كم سنة اللي هو العمر عند الوفاة، وبالتالي أقدر أحدد من خلالها الأمراض اللي هو عانى منها، بالإضافة للجندر بقى السكس هو ميل ولا فيميل. ففي بعض الفيتشرز او المورفولوجي اللي احنا ممكن نقول عليها اللي ممكن من خلالها احدد الميل او الفيميل على البونز، زي مثلا السوبر اوربيتال ريج اللي هي منطقه الجبهه، اللي هي المنطقه دي. فالمنطقه دي بتكون اكبر في الميل، بتكون اصغر شويه في الفيميل. وكذلك منطقه الفك او الجو اللي هو اللور جو، بنلاحظ ان هو في الميل بيكون سكوير، في الفيميل بيكون واخد راوند شاين كده. كمان منطقة المستويد بروسيس أو منطقة أسفل الأذن هنا بتكون أكبر في الميل، بتكون أقل في الفيميل. أما بالنسبة للإيدج ديترمينيشن اللي هو تحديد العمر، فده تم من خلال السوتشر لاين كلوجر، وهي مناطق التحام العظم بتاع الجمجمة. يعني نلاقي مثلا إن الأطفال وهم صغيرين في السن بيكون العظم بتاعهم متباعد عن بعضه، فكل ما الإنسان بيتقدم في العمر كل ما العظم ده بيقرب، فكل تقارب للعظم مع بعضه ده بيديني ديجري في الاكسل شيت بتاع العينات عندي. فمثلا الاطفال في عمر صغير 0، والميدل ادلت اليونج ادلت عطتهم 1، الميدل ادلت اللي هو من 34 ل 45 ده ديجري 3، اما الاولد ادلت اللي هو بين 60 فيما فوق بقى فدي 0 اوبلريتد، لان خلاص العظم بالتالي التحم. كمان احنا ممكن نعمل الايدج استيميشن من خلال البونز، من خلال الدنتال اربشن اللي هو ثوران الاسنان، يعني انه من خلال انه نمو الاسنان بتنمو على فترات عمريه مختلفه، فبالتالي ممكن من خلال بس ما ابص لفك بتاع هيكل عظمي اقدر اعرف هو عمره قد ايه. الميثودولوجي انا خلصت كده الايدج والسكس، ثم بعدين كان لازم ابص على البلانت ريمينز اللي اتلقت في الموقع علشان اقدر اعرف هم كانوا بياكلوا ايه من خلال البقايا اللي هي البلانت ريمينز اللي تم العثور عليها في الموقع. اول حاجه ودي اهم حاجه هي البيرلي والويت، او اسمها باللاتيني الهوردن ديكوكم والتريتيكال ديكوكم، ودي كانت مكونات البريد في الانشنت ايجيبت. كان تم العثور على قطعه من الخبز المتفحمه وتم تحليلها فعلا في معهد الاثار، في معهد الاثار الفرنسي في القاهره، وفعلا عرفوا ان هو مكوناتها ما بين القمح والشعير، فعرفوا انه في الفتره دي كانوا بيعملوا العيش بتاعهم من قمح الامر اللي هو تريتيكم دايكوكم، والبيرلي اللي هو الهوردن دايكوكم. كمان ايوه خلاص كمان كان اهل المعادي كانوا بياكلوا البي او البسله اللي هي البيزيوم باللاتيني، بالاضافه لللينتل اللي هو العدس. كمان كان في بذور في الموقع للفاكس او اللي هو اسمه التين البرشومي، بالاضافه للكومسيوم بالون او اللي هو الشات ميلو، ده بالمصري كده اسمه القته، هو حاجه مش خيار ولكن هو شبه الخيار ولكن مخطط كده، وده كان بيحتوي على نسبه كبيره جدا من الالياف اللي بتساعده ان هو يشبع فتره طويله، فبالتالي ده من ضمن الغذاء اللي كان بيعتمد عليه في فتره وجود جفاف. اما بالنسبه للانيمال ريمينز فتم العثور على عظام لحيوانات الكاتل ده اللي هو الابقار والماشيه، بالاضافه للشيب اللي هو الاغنام. البيجز الخنازير، ولكن الخنازير ما تمش العثور على كات بوردز مثلا انها بتشير انها كانت بتتذبح، لان هم كانوا بيستخدموا الفيجز لان هم بيبذروا البذور في الارض ويخلوا الخنازير تعدي عليها علشان تدوس البذور دي جوه الارض، وبالتالي الزرع يطلع، لانه ما كانش عندهم الالات الحديثه زي اللي موجوده دلوقتي. بالاضافه للجوتس، ده من ضمن الاكل، من ضمن العظام اللي كانت كتيره قوي في الموقع. الهير او الليبياس سبيشالز اللي هو الارنب البري، ولكن برضو ما كانش فيه علامات ذبحه على العظم بتاع الحيوان، وهم بيعتقدوا ان هو كان بيربيها بس من باب التربيه، يعني في بعض الحيوانات كانت بتربى وبعض الحيوانات كانت بتؤكل. ايضا هيباتويتس او الفرس النهري. اشهر بقى المأكولات البحريه عندهم كانت الكاتفش، واللي هو السلار ده باللاتيني، وده سمك القرموط. ده سمك كان بيتربى في المستنقعات، فبالتالي هو ده السمك اللي تقريبا كان بيتلاقى اكتر حاجه لما بتيجي امطار لفتره كبيره جدا على النيل، فبيرقد بيعملوا مستنقع، يعني الميه بتعمل مستنقع لفتره طويله، تيجي اسماك القرموط بتعيش فيها لفتره طويله، فبالتالي هو اكتر بقايا عظميه للاسماك بالذات تم العثور عليها. بعد كده بدات ان انا من ضمن الميثودولوجي طبعا ان انا ارصد بقى الامراض اللي على العظم عشان اعرف الافكت بتاع الفود على العظم ده. فكانت اول مرض، او يعني المرض اللي لفت انتباهي قوي ان هو قليل، هو الدنتال كاريس، اللي هو تسوس الاسنان، وهو بيظهر زي ما بيظهر عندنا احنا دلوقتي، نخر في منتصف السن لونه بني. ثم النخر ده لو ما تعالجش بيسبب ابسس، فيخلي السنه زي ما ظاهر فوق كده، مش عارفه الجزء اللي فوق ده، انه السنه خلاص هتفقد لان الشخص ده جاله ابسس لفتره طويله، وطبعا ما كانش فيه تريتمنت يتعالج، فبالتالي الاسنان دي بتبقى بري مورتم ديزيز. تاني مرض، وده مشهور جدا في مصر القديمه مش بس في البري هيستوري، اللي هو دنتال اتريشن. والدنتال اتريشن هو انه تاج السنه نفسها لما بنيجي نبص عليه بلاقيه ان هو متآكل، يعني احنا اسناننا كلها فيها شويه من الكاس بس كده عظم، اللي هي بنقول عليها تعريجات السنه. فلما بنشوف الدنتال اتريشن ده بريفير ان الشخص ده كان بياكل سيفير فود لفتره معينه، يعني اكل فيبرس، اكل خشن، اكل ما كانش بيطبخ بشكل جيد. وده بيرجع لي واحد من ضمن التماثيل اللي موجوده في الايجيبشن جريب ميوزيوم في المتحف المصري الكبير في مصر، لسيده، شكل سيده وهي قاعده بتعجن الخبز بتاعها على ماسكه كده المطرحه، يعني بالمصري اسمها مطرحه، مش عارفه في يعني الدول العربيه اسمها ايه، ولكن هي بتعجن الخبز على قاعده كده مصنوعه من اللايم ستون، من الحجر الجيري. طبعا وجود الحصى بيختلط بالعجين، فده بيسبب ان الاكل بيكون فيه بعض المواد اللي بتعيق عمليه المضغ بشكل جيد، فده بيسبب سيفير دنتال اتريشن. الدنتال ابسس ده مرض ريليتد بالدنتال كاريز، وده بسبب انه الشخص ده بيتناول كميه كربوهيدرات بكميه معينه بتسبب تسوس، وده طبعا بيريفير ان هو ما كانش عندهم اي نباتات للعلاج، يعني كل النباتات اللي فاتت دي كانت نباتات فقط للاكل. فبما ان احنا نلاقي عدد من الدنتال ابسس، فده دليل على ان الشخص ده ما كانش بيتعالج لفتره طويله، فالتسوس او الكاريس سبب ليه ابسس. الكالكولس ده بيريفير ان الاشخاص دول، انت بتكلميني؟ I don't see you يعني. اوكي. الكالكولس بيريفير ان الشخص ده بيتناول بروتين كبير لفتره كبيره جدا، وبيظهر على هيئه تكلسات على سطح السنه. اخر مرض معانا هو البريدوندال ديزيزز، وده ارتشاف العظم الداعم للسنه. ده بيشير ان الاشخاص دي كانت ما بتهتمش باسنانها زي ما بيقولوا، ما عندهاش هايجين كير للاسنان، لانه الاكل اتحشر جوه اللثه، وسبب انه فضل اللثه تلتهب لحد ما فقد العظم الداعم للسنه، والسنه دي خلاص يعني في تعداد انها خلاص هتبقى بري مورتم، هتفقد يعني. ده شكل الاكسل شيت اللي انا جمعت فيه بقى النتائج. العمر الفلاني، كان عدد اصابات امراض الاسنان فيه في الكاريز قد كذا، وفي الابسس قد كذا، وفي الاتريشن قد كذا. فده شكل الاكسل شيت الخاص بالاحصاء يعني. ودي كانت النتائج، إنه التسوس كان أقل نسبة، أما التآكل كان النسبة اللي قبل الأخيرة، يعني التآكل 81%، ده كانت نسبة تعتبر كبيرة جدا. بس بالمقارنة بالكالكولوس ومقارنة بالأبسس بنلاحظ إن هي أقل، والبريدوندال ديزيز ده النسبة كانت الأعلى. أما بالنسبة للسكس فبشوف إنه الفيميل كانت أعلى، النصيب الأكبر يعني نصيب الأسد في الدنتال ديزيزز. وأما بالنسبة للإيج في اليونج أدلت كانت أعلى في أمراض الأسنان مقارنة بالميدل أدلت والأولد أدلت. آخر حاجة عشان ما أطولش عليكم عشان نسرين هتقتلني هي الدسكشن والريزالتس اللي هي بقى الكونكلوجن لكل الدراسه دي والاحصاء، هو ان الدنتال كارز كان حصل بنسبه قليله، وده بيريفير ان الاشخاص او انه المعادي بوبيوليشن كانوا بياكلوا كربوهيدرات اقل، فبالتالي النسبه بتاعتهم اقل، والكربوهيدرات المخبره دي زي السكريات زي النشويات. اما بالنسبه للكالكولوس فسجل نسبه اعلى، وده بيديني ريفير ان الاشخاص دي كانت بتعتمد على البروتين بشكل كبير، على الماشيه والاغنام في الاكل اكتر من اعتمادها على الكربوهيدرات. بالنسبه للدنتال اتريشن ده بيشير لي ان الفود بتاعهم ما كانش بيطبخ بشكل جيد، يعني كان اللحمه ما كانتش بتطهي بشكل جيد، وكانوا بياكلوا اكل ليفي خشن، لذلك سجلت نسبه اعلى. الابسس ريليتد بالكارث، فبالتالي النسبه بتاعته بتكون مرتبطه تقريبا بنسبه الكارث، فهي قليله 35%. والبريدوندال ديزيزز بتريفير لي ان الاشخاص دول ما كانوش عندهم زي ما قلنا هايجين كير للاسنان، لانه لما يكون عندي مرض سجل في مجتمع عباره عن 54%، المرض سجل 63%، ده معناه ان الاشخاص دول ما كانش عندهم هايجين وما كانش عندهم وسيله لعلاج امراض الاسنان اصلا، وكانوا بيتناولوا اي اكل بيلاقوه طبقا طبعا للتغير المناخي اللي هم كانوا بيمروا بيه. كمان الانسيدنس بتاعت اليونج ادلت مختلفه عن الميدل والاولد، فنلاقي مثلا ان اليونج ادلت النسبه عاليه قوي، وانا بشوف ان ده برضو منطقي معانا، يعني احنا كلنا اعمار مختلفه، فبالتالي انا باكل اكل يتناسب مع اسناني، وفلان بياكل اكل يتناسب مع اسنانه، وفلان وفلان وفلان، فبالتالي ده برضو كان بيحصل في المصري القديم، كان اليونج ادلت الستايل او اللايف ستايل بتاع الاكل بتاعه غير الميدل غير الاولد، كل واحد ليه عمر معين. كمان انا بريفير الحته دي انه انا وانا شغاله في عينات البقايا الادميه، انا عندي مجتمع كبير جدا من الاولد ادلت، الاولد ادلت ده من 60 في بلس لفوق، الاشخاص دول اصلا اسنانهم بري مورتم ديزيزز، فقدوها قبل الوفاه بسبب الاصابه بالسيفير يعني لامراض الاسنان، فبالتالي اصلا لا يمكن رصدها بشكل طبيعي زي اليونج ادلت اللي اسنانهم لسه موجوده في العينات. دي some of the references if someone يعني interested in the climate changes or fauna and the flora in ancient Egypt. And thank you so much.
Thank you, Ms. Hager. So now, the stage for Ms. Nihel Ziadi.
ثانكس نسرين. قبل ما نبدا ما تحسبيش في الوقت هذا، نحب نشكر ASREN ومركز الخوارزمي على التنظيم الرائع للمؤتمر وعلى المداخلات اللي كانت رائعه. نبدا توا. Thank you. I present you, I'm Dr. Nihel Ziadi from University of Tunis Al-Manar, and I present you our presentation. The title is Playful Learning in the Age of Advanced Technologies, How AI and HPC are revolutionizing education through play. And teaching through play is a teaching method based on the use of playful activities to facilitate learning, and many researchers have explored the benefits of this approach and demonstrating that it can stimulate motivation, active participation, and knowledge retention in learners. Like Jean Piaget in 1936, play is crucial for children's cognitive development through playful interactions. And Lev Vygotsky in 1978, social play supports learning, helping children surpass their limits through the zone of proximal development. And David Shaikhah in 2004, digital games create authentic learning environments, fostering real skills through playful engagement. So our hypothesis, the first hypothesis, that the game improves learning's motivation and commitment, has a positive impact on the perception of the role of leadership and the small businesses in society. And the hypothesis two, gaming promotes social and collaborative learning, has a positive impact on the perception of the entrepreneurship as a career path. And the hypothesis three, games help to develop complex cognitive skills and have a positive impact on knowledge of leadership, small businesses, and the challenges they face. Now, this hypothesis aligns with exciting work in the literature, and as a part of our teaching experience with the Know About Business program, training program of the University of Tunis Al-Manar with doctoral students, a methodology based on games was adopted, and practical experimentation was also implemented. And this process took place over 70 hours of training and made it possible to collect data via questionnaire from 20 doctoral students, including 15 women and 5 men. And the results, observation after studying the KB, the Know About Business program, highlights significant achievements in learnings. And the key improvements that enhanced mastery of entrepreneurship vocabulary, increased confidence in their ability to learn. And the Know About Business program influences learners' perception of self-employment. Our results, and according to our case study, we are able to obtain a learning assessment rate of £4.22 for the doctoral students. And so to improve this system, you are thinking of integrating artificial intelligence technology into my future experiments. And why? Because you think that personalizing learning with AI, analyzing learning's interaction with educational games to tailor connect according to individual needs and challenges, enhancing personalizing learning. And two, we think that learning data analysis and optimization, advanced data management tools, and HPC help educators track interaction and optimize game mechanics for better educational outcomes. And the third proposal, that complex simulation and immersive environments. And we think that real-time feedback and performance production. AI offers real-time feedback on learners' performance and predicts future outcomes. And 5, you think that AI, we can benefit with collaboration and networking learning. I need our program is a program of the International Labour Organization, and it's an entrepreneurship education program development to teach entrepreneurship in the university. And it's a program collaborated with the ILU and our higher ministry. And I will took place to view our video the program training in our university.
The time is 4 o'clock
شكراً.
p.m.
4, 3, 2, 1. Yes. Thank you very much. Please, Mr. Youcef. Would you like to use the mic or? Yes, okay. Please, English or
Hello, everyone. My name is Youcef Benrached. I am a Master's 2 student in Artificial Intelligence at the University of Khamis Miliana in Algeria. So our research here today is about automated medical labels text extraction using fine-tuned Tesseract here in Algeria. So this is the outline that we will follow here for our presentation. And for the introduction here, so in Algeria, we have these medical labels. They are these small stickers that you can find in medicines. And these stickers actually have vital information about the medicines, such as the dosage, the price, whether the medicine is refundable or not. So it is very vital and crucial for a piece of information. But the problem is that insurance companies or pharmacies rely heavily on manual verification of these labels. So every day they have to deal with hundreds, if not thousands, of medical labels, and this process is actually very prone to human errors, and it's very time consuming. So our proposed approach here aims to streamline this entire process, and it uses an AI model to detect the text within these medical labels. Then it's followed by object detection, optical character recognition, and you can even classify these medical labels using this AI model, and you can finally automatically save the information in these medical labels. So why we chose this research, because as we mentioned, pharmacies and a lot of insurance companies rely on the manual verification, and yeah, this diminishes the value of the medical labels. And this workflow is very time consuming, and it's very prone to errors. So we are aiming to automate this entire process to hopefully, so they can hopefully use this approach to save time and for the workers' sake. So these are a few related works that are relevant for our work today. So to summarize it for you, there are three categories for OCR. For clearance, OCR means image to text. So if you see OCR, it just means that you transform an image to a text. So there are traditional OCR methods that use computer vision approaches like segmentation, histogram, edge detection. And these approaches are actually very fast, but the problem is that they're not very flexible, and they perform poorly in noisy environments, so they can't be very reliable. So that's why Tesseract OCR was developed. Although it covers a vast variety of documents, but the problem is that in these special use cases, for example, in the medical labels, it performs very poorly. So that's why AI-based OCR was developed, because it actually, like Google Lens, for example, it uses deep learning techniques like CNN and RNN, but the problem is that they demand a very large amount of labeled data and a significant amount of computational resources. So the Tesseract-based approach here is the initial step for our work here. So for the data set that we used here, it's actually, we had to create this data set from scratch. There was no available data set in all of Algeria. And these are what medical labels look like. And we had to collect over 1,000 images, and we had to manually document the content of these medical labels in an Excel file. So we had to create the whole data set from scratch. So this is a Tesseract-based approach. This is the initial step, as I mentioned. It takes the data set and it takes an image input, and from it goes to the first phase, which is the detection phase of the medical label. Then it's followed by a segmentation, and thirdly, an OCR process. So the first phase here is the medical label detection phase. So you take in the image of the medical label, then it's followed by the selection of the four corners of the medical label, then the extraction is done. So this whole process is now actually done by an an AI model called YOLO. So we created another AI that does the object detection for us. So now this entire process is now done by an AI. So the next step now is the segmentation phase. So here we used a histogram, which is a computer vision approach, and we used histogram to segment the horizontal and the vertical parts in the medical label. So here we used a vertical histogram. Then here we used a horizontal histogram to separate the line of text individually. So the third phase here is the OCR process. So each line of text individually goes to the Tesseract OCR. So each line of text goes one by one to further increase the accuracy. Then there is the label classification, which is done by color detection. As you can see here, there are two classes. Red labels are non-refundable, and the green ones here are refundable. So for our contribution here is the fine-tuned Tesseract. So we had to create another data set for the fine-tuning process. So we had to actually crop the lines of text in these medical labels and create their corresponding ground truth text file. So we here created about 1,200 images, and we also had to create their corresponding ground truth, which is the text in the image. So each image has its own text file that has the text of the image. And you have to make sure that the name match and the ground truth or the text actually matches what's in the image. Otherwise, the model will perform poorly. So the next step here is actually creating the box file. So you feed there's a Tesseract box creation script that takes the image and the text file as an input, and it creates a box file. This box file has the coordinates of the text in the image. So it looks at the text, and it creates the coordinates of that character in the image. So those values that you see here are actually the coordinates of that character in the image. So the third step here is to combine all these files, the image, the text, and the box file, in one LSTM file. And these LSTM files are what we will be the input of the Tesseract model. So the fine-tuning process here takes actually two inputs. It takes the data set that we created and the trained data file. The trained data here is the model initial weights. So we used French here because the medical labels are written in French. So the trained data is the initial weights, and the data set is what we collected. So once the fine-tuning process ends, it creates a new weights model specifically made for recognizing the medical labels. So for the training results, you can see that accuracy went from 80 all the way to about 86%, or 85, I should say. And the binary cross-entropy loss is just a binary value of whether the predicted character is correct or not according to the ground truth. So you can see here that the BCER loss is about 14. So the experimental results here show that our fine-tuned Tesseract actually outperformed the standard Tesseract. So the accuracy went by about 17%. And you can see the highlighted red are where the standard model was wrong. And after the fine-tuning, you can see where it improved. So for the conclusion here, we actually developed an AI-powered process that can streamline the entire text detection of the medical labels. And this can be used by pharmacies or insurance companies. And it can be even used for creating a standardized OCR model in all of Algeria. So the key modifications here is that we actually created a data set specifically for medical labels, and it's completely labeled. And we also created a fine-tuned Tesseract specifically made for medical labels. And the results showed about an 84% accuracy of the OCR. So for the perspectives here, we would like to optimize the hyperparameters of the future fine-tuning processes. And we also like to expand the data set because that's actually the most exhausting part of it because you had to manually label and crop the images. So that was very time-consuming. And yeah, we also like to integrate other advanced models like LLMs, for example, so that when it reads the medical label, it can generate a brief paragraph or about the medicine or on when it can be used or other side effects, for example. So yeah, thank you all for listening to me. And if you have any further questions, please ask.
Thank you very much. Please, Ms. Samia.
Hello, everyone. So from the pharmacy, I will take you in a journey through the medical lab. English all the time, right? Yes. So I'm Samia Benadda. I work in microbiology lab in Algeria, and I'm here to talk to you about artificial intelligence in image analysis in microscopic slides in microbiology. Actually, infection diagnosis might be very complicated, especially when it comes to bacterial infection. In fact, we need to distinguish between the bacteria that normally lives on our body, which is called microbiome, from the pathogen bacteria. And for this bacterial identification, we go through different steps. First, the sampling. We can receive different kinds of samples, and then the microscopic examination, and finally the culture test. The culture test consists on putting the sample on different culture media and incubate them overnight. And by magic, the next day we will see colony. These colonies need to be identified. How do we identify the colonies? First, by microscopic examination, and the most used microscopic examination is the gram stain. The gram stain is the first step used, and depending on these results, we will make other biochemical tests and antibiotic testing. The gram stain has been discovered in 1884 by Hans Christian Gram, and is the first test performed in microbiology and is widely used nowadays. It is based on the thickness of the cell wall of the bacteria. Actually, it happens this way. We put the first dye, which is purple, on the bacteria. All the bacteria will get the purple dye. Okay? Then we use alcohol to decolorize the bacteria. And guess what? The bacteria with a thick cell wall will not lose the purple dye. Okay? It will stay purple, and we will call it gram-positive. But the bacteria with thin cell wall will not retain the purple dye, and will get the second dye, which is pink, and will appear pink. So it is gram-negative. So in this picture of gram stain, you can see the shape of the bacteria, which is round. We say cocci. And it is purple, isn't it? So we say it is gram-positive. And we see how the bacteria is grouping, and here we see that they are grouping in clusters. All these information can make us guess that this bacteria is Staphylococcus. Okay, all this work is done for thousands of bacteria. All this information might be confusing and time-consuming. So we thought, what if AI can help us? Generally, the machine learning goes through 3 steps: the data collection, the training of the machine, and then the clinical validation. In this work, we challenged AI, and we tested the results or the answers given by AI in front of qualified human microbiologists. So we started by codifying the answers, and then collecting the images. We collected 180 images from 13 gram stain slides from 10 bacterial species. The pictures were taken by our cell phones. And we tested some famous, previously trained AI systems that you all know, the Gemini and the ChatGPT. So we said, hey, ChatGPT, act like an expert in medical microbiology and try to guess the bacteria in this image. Same thing with Gemini. And here are the results. So for 7 species, the AI gave 3 good answers on 7, but the qualified microbiologist had only 5 on 7 good answers. And comparing GPT to Gemini, we see that it is the same number of good answers, but in different species. And when we go into details about the shape and the gram stain of the image or of the picture, we see that Gemini was more accurate than GPT-4. So in other studies, we all find the same results. It's good specificity, good sensitivity, and good accuracy, like in this paper published in 2020. And if we do a search on PubMed using the keywords artificial intelligence and medical field, we find more than 10K papers published nowadays in different fields like tuberculosis diagnosis, tumor detection, radiology and imaging, and ECG interpretation. So finally, I can say that AI can be very useful in the medical lab, especially in pre-classifying and pre-screening the gram stains. But the data collection needs automation to get big data. And finally, once settled, it can improve productivity and accuracy in the lab. And in final, it's not that expensive, as it will help remote diagnosis. And thank you.
Thank you very much. Please, Dr. Radwan.
مساء الخير جميعا. صح اصحوا شوية. نمنا؟ يسعد مساكم. This presentation is about leveraging AI to forge zero trust security in smart meters, Internet of Things systems. It has been done as a research by my student Dania Abu-Rish, and because she has a newborn, she couldn't come here, so I will present her work. And she has an applied research idea to work for development of a new system, secure system for smart homes and for smart cities. So, as we know, Internet of Things, they have the capabilities of pursuing, sensing, and exchanging data. However, they are subject to so many attacks. So assume that you have a smart home with different devices, and assume that some of these devices are attacked by intruders. And if you are sleeping in your bed and you notice that the air condition has switched from hot to cold, for example, while sleeping, or you can feel that the oven is turned on for cooking at 2 o'clock at night. So it's not acceptable, isn't it? If it is acceptable, then if your husband is cooking at 2 o'clock every day and the oven is working at 2 o'clock midnight, then there should be something strange. However, we assume in our model that every device has its identity and every device in the home is connected to the smart meter or to the network as an Internet of Things device. However, in this work, we propose an AI-driven zero-trust security model for protecting such smart meters based on user behavior and consumption patterns. What do we mean by this? Okay, I know that each device in my home is working according to a certain pattern. For example, we know that the air condition is working after we come home from work. So it's not normal to see the air condition working, for example, at 10 o'clock, for example. Assume that the refrigerator in the winter is consuming less power than in summer. So each device, smart device in our home, has a specific profile, and it depends on the user behavior of the home and of the owner of these devices. However, when these devices being attacked by intruders from outside, so I cannot make sure which device is causing the problem. In our model, we will incorporate a new concept for smart homes or for smart devices, which is called zero trust. Zero trust means do not trust anything. Always verify every action of your network devices or your smart devices. However, having profiles being managed by our system, then also we can make sure that the consumption and the management of the electricity consumption of each device is also following the expected profile or the expected behavior of this device. Okay, these are the cybersecurity challenges. So in our home, assume that we have in our smart home, we assume that we have all devices are connected. The smart grid is situated in 2 levels. I had the previous students working on different levels. I had the student previously worked on the DCU level, I mean on the region of the electricity distribution. One important note for the importance of this applied research is that our municipality in Hebron city declared that they are losing 23% of their revenues from technical and non-technical losses. So we have to know, in fact, where each kilowatt, or if we can, where each watt is going in our system. So this model, we go fine grain, and we go to the level of each device and know the consumption and the behavior of each device in our system. So smart meters are essential IoT devices offering real-time energy usage data. So this is also an important issue for these devices. They are consuming electricity in real time. Smart metering involves gathering, monitoring, and analyzing consumer energy consumption in real time and using smart meters. We assume that each home is connected to a smart meter, and all devices are also connected and managed by this smart meter that is being supplied by the electricity company. The concept of zero trust is, as I explained before, do not trust anything. So you have to verify and identify each device. You have to authenticate each device. You have to limit the access with the least privilege concept and segmentation of these devices. The interesting part here that we added also, we have to monitor each device continuously and to study the behavior and analyze the behavior of these devices based on their users and the usage of these devices. We are talking about each device in the home as a separate device. Also, we can take the profiles of the standard manufacturers of these devices. So if the manufacturer says that this device is consuming, for example, 10 kilowatts per hour, then if my device or my refrigerator or my air conditioner is consuming more power than the standard power that has been declared by the manufacturing company, then it means that there is something wrong, which I can detect that there will be an error or intrusion or any other management issues. So the basic idea, Dania will analyze the parameters. So we'll also have she will start creating the profiles for each device, and then we'll train an AI machine so as to make sure that every device when is being used follows the expected behavior. And if something wrong is going on, the machine learning or the smart device, the smart meters, of course, in communication with the electricity company, will alert the system so as to make sure that everything is okay. She did a very excellent literature review about the smart metering systems, the smart grids, and she did also a very well literature review for zero trust models. However, for time limitations, I will skip this part. However, as part of the solution, she will continuously authenticate their devices. She will go to rigorous logging and auditing. So we have a huge amount of generated data from all homes in the city, for example, and then will be managed in the electricity company. So also we have the concept of device isolation. So this approach aims to create a secure environment by thoroughly monitoring and controlling all interactions within the smart metering system, ensuring data integrity and privacy. And this may be the proposed solution actions that should be taken for detecting these abnormalities for each device in our smart home. So the methodology, she will create an AI model development. She will simulate the results, because it's very difficult to have huge data or benchmarks for existing devices. We have some data, but we will create or increase the amount of data to be tested, assuming that we know some information about each device in our home. Also, then we will do the device profiling and access control. We will start then detect any abnormalities or anomaly detection, and through testing the system. So in summary, the expected contributions is to have a zero trust model utilized for smart metering Internet of Things systems. It will be AI-driven profiling for real-time threat detection. We will be validating through simulation of a real-world environment. She used a good set of references and bibliography, and I hope that she will be successful in continuing her research and finishing the idea for her applied research. Thank you very much for hearing us.
Thank you very much. Please, Dr. Asma.
Good afternoon. I'm Dr. Asma Hadiwi from the University of Sousse, and I'm honored to present the Adaptive Intelligent Collaborative E-Assessment Framework that is a solution implemented and tested to overcome the shortcomings of traditional methods of assessment in collaborative e-learning environments. So let's start with a scenario many of you may relate to. Imagine a group of students working on a collaborative project. One student makes the whole work, another struggles to understand the role, and a third remains disengaged. At the end of the project, traditional assessment assigns a single grade for all the members of group. So it fails to capture the nuanced contributions and interactions. This scenario underscores a key challenge in collaborative learning: how to fairly and accurately evaluate contributions, interactions, and learning outcomes that traditional methods overcome. The Adaptive Intelligent Collaborative E-Assessment, or ASIA framework, aims to fill these gaps. It is designed to adapt assessments in real time, ensuring they reflect dynamic group interactions and individual progress. The framework also focuses on fostering equity within group dynamics and enhancing student engagement through personalized feedback. The ACA framework integrates advanced technology. First, we have the generative artificial intelligence, which creates dynamic and context-specific tasks, ensuring they evolve in real time to match learners' interactions and needs. Second, we have the ontological modeling, which aligns assessments with the unique competencies of individuals and the dynamic of the groups. And third, we have the predictive analytics, which tracks learners' progress and group interaction. The framework's component further support this technology. We have the predicting group disengagement, exploring gender disparities in group composition, optimizing group formation, determining the suitable peer group for peer assessment, project allocation that will affect the project to the adequate group based on the collective skills in each group, task assignment optimization in the group will affect the task to the suitable member that have the skill to do it, feedback generation, post-prediction, adaptive real-time task adjustment, and generative AI for scenario and content creation. Here is the architecture of the ASIA framework, which operates across 5 key layers. We have at the top the user interface layer, designed for seamless interaction. This layer provides interfaces for both instructor and students. Then we have the AI tools integration layer, which contains the AI chatbot, the ASIA chatbot, which helps students with correction, hints, and feedback. After that, we have the knowledge and modeling layer, uses an ontology-based knowledge module to align tasks with learner competencies and support comprehensive evaluation. We have also the assessment engine layer, which is responsible for task and project evaluation. And finally, we have the feedback, which is responsible for the generation of real-time feedback. To evaluate the ASIA, we conducted a pilot study with 250 first-year Python programming students at the Higher Institute of Transport and Logistics of Sousse, University of Sousse. Participants were divided into 2 groups, one using ASIA and the other relying on traditional methods. Assessment scenarios focused on dynamically assigned tasks, collaborative problem solving, and iterative feedback mechanisms. The goal was to measure how effectively ACA supports both individual and group learning processes. The pilot study revealed significant improvement in learning outcomes for students using ACA. Assessment accuracy improved by 30%, critical thinking and problem-solving skills saw a 25% boost, and engagement increased by 35%. The results were rigorously analyzing using statistical methods, including t-test and ANOVA, confirming their significance. As you can see, we have P less than 0.05. Additionally, student feedback highlighted high levels of satisfaction with personalized feedback and adaptive challenges. This demonstrates ACA's ability to address diverse learner needs effectively. Ethical considerations are foundational to our ASIA. Privacy is ensured through anonymization, while algorithms are designed to mitigate bias in group formation and task allocation. Transparency is promoted through real-time feedback, and Sparkle-based reasoning facilitates data usability and scalability. These measures build trust and ensure fairness in the application of AI-driven assessment. The future of ASIA lies in its scalability and adaptability. We aim to expand its application across multiple disciplines and educational levels. Federated learning will enable secure, large-scale implementation, while open science initiative will foster collaboration by sharing interoperable datasets and tools. These advancements will position ASIA as a cornerstone of intelligent educational assessments. In conclusion, ASIA is more than an assessment tool. It is a vision for inclusive, adaptive education. I invite you to imagine a world where assessments are fair, dynamic, and inclusive. And together, we can make this vision a reality. Thank you.
Thank you very much. Please, Dr. Inas.
No, in English. Good afternoon, ladies and gentlemen. It's a pleasure to present my work in this section of Young Arabic Research. First of all, I will present myself. I am Ines Esbei. I am a current assistant professor at the High Institute of Computer Science of KEF. I earned my PhD in computer science from High Institute of Management of Tunis in 2021. Currently, I'm a member of Larodec Laboratory. My current research interests include combinatorial optimization problem, include transportation problem and logistics. In the personal research practice, I addressed 9 problems in the field of transportation, logistics, big data analytics, and supply chain. I also addressed 5 real-life applications, such as Tunisian Post Office, big data analytics for Tunisian and waste collection transportation in Tunisia, also pilgrims transportation problem in Saudi Arabia. To solve this problem, we used 8 intelligent algorithms, such as genetic algorithm, hybrid genetic spark algorithm, adaptive chemical reaction optimization algorithm. Our work are published in 6 international journals with a high impact factor. 8 international conferences and 2 chapter books. As you can see here, we have our journal that I and Professor Sausen Krishan published our works. Here we have 6 international conferences, 2 chapter books, and 7 national conferences. We have 3 submitted papers in international journals. Our work, our abstract in this EH, la conférence n'a pas mis à jour la présentation. Je vais présenter mon abstract. Our proposed submitted abstract for the EH conference entitled Artificial Intelligent Algorithm for Ambulance Routing Problem, Hospitals Case Study, proposed by me, Ines Sbai, and Professor Sausan Krishan. In order to find a solution for ambulance routing problem, we used intelligent algorithm, named as hybrid genetic algorithm and Spark, where a huge number of data generated in dynamic ambulance routing problem can be stored, managed, and analyzed, processed using big data analytics. Limited access to resource and training, especially data collection for the challenge, keeping up with the rapidly evolving technology, managing interdisciplinary data and tools. For the proposed solutions, we have to investigate a training program for data and skills, forest, regional and international collaborations, develop policy that promote open science, and finally, build digital infrastructure to support research. Thank you for your attention.
Thank you much. Thank you very much for everyone. So now that we heard from all, let's start the voting process. Yes. Yeah, if you have any questions, please. To any of the researchers. Yes? Okay, let's start the voting. So you have 3 minutes. Please scan the QR code and vote for the best participation in your opinion. Sorry? Yes. Okay, okay. So is the QR code is working? Okay. So while you vote, please, Mr. Youcef Turman for the closing, or we have the chair, Zainab. Okay. Sorry. Yeah. Sorry? Okay. So we would like to thank our young researchers for their great efforts. And I would like to thank especially the people behind the scenes that was working for the selection process, Dr. Rawiya, Dr. Safa, Dr. Wafa, and Irina Joy. Thank you very much for your great work. Thank you.
حان وقت الإعلان. حان ولا ما حان؟ حان وقت الإعلان عن الفائز وبالنسبة لليونج ريسيرشرز. أنا ما إلي علاقة في الموضوع.
مبروك.
يوسف. كمان ندعو جميع الباحثين الشباب اللي قدموا عروض اليوم، لو سمحتوا تفضلوا، حتى يعني شغله رمزيه هي تتذكروها مع بعض. انا وكمان اسمحوا لي ادعو مفاجاه رقم اللي هي مدام عواوش المهاب بتقدم لكم الميداليات. تفضلي مدام عواوش. مدام، طبعا اللي ما بيعرف مدام عواوش المهاب هي من مؤسسين آسرن، وهي تعمل بصمت، يعني هي من الناس اللي يعملوا بجد ولكن بصمت، يعني لا ليست من وراء تهدف الى الظهور كذا، ولكن احنا نقدر ما تقوم به في للجزائر ولا آسرن، يعني هي من مؤسسين آسرن، فحبينا انه يعني تساهم معنا على الستيج، تقدمي لهم الميداليات اذا سمحتي. تفضل تفضل. الميداليات هناك مع نسرين.
اوكي.
تفضل.
دكتورة أمل شيخة.
خليها هنا جنب العلم.
لما نادي فريق سيسكي وبدي عبد الوهاب وزهرة. طيب خلي نسرين تحاول لما تنادي، بما انه بدي تعطوني واحد ولما نادي مشكورة. خلي نسرين بس خليك تتصل عبد الوهاب. اوكي خلص. بس خلص. And خلصوا. And the youngest potential researcher
زينب أي future young researcher.
كل حصة خلصنا. طيب هلا بدي انادي فريق سيسكي. شكرا. لا الدكتورة في لك شغله ثانيه، خليكي معنا على الستيج، لا تنزل. لا تنزلي.
يوسف نعطي ليوسف كمان واحده.
اعطيها. لا اعطي اثنين، اعطي يوسف واحد، هو ضلك اثنين. زميلته اللي هي لدانيا وواحده ليوسف.
مدام عوش ليوسف.
لا مدام عوش في لها شغله. خلص انا بدي اعطيها شغله ثانيه.
دوينر كمان مره.